need to track every operation in your FastMCP server for debugging, auditing, or performance monitoring. You'll see how to implement a simple logging middleware that intercepts all MCP messages, logs their execution start and completion, and passes control seamlessly to the next handler, all with just a few lines of code. This pattern forms the foundation for building more complex monitoring, analytics, or even security middleware in your FastMCP applications. From FastMCP, import FastMCP. From FastMCP server middleware, import middleware. Middleware context. Class logging middleware. Middleware. A middleware that logs all MCP operations. Async def on message, self context. Middleware context call next. Called for all MCP messages. Print F processing. Context method from context source. Result equals await call next. Context. Print F completed context method. Return result. Hash add middleware to your server. MCP equals FastMCP. My server. MCP. Add middleware, logging middleware. This demonstrates the middleware pipeline pattern, a chain of responsibility implementation tailored for model context protocol operations. The concept creates modular interceptors that wrap core server functionality, allowing you to inject cross-cutting concerns like logging, authentication, or rate limiting without modifying the underlying components. What makes this distinctive is its protocol-aware design. Unlike generic HTTP middleware, it operates at the MCP message level with hooks for specific operation types like tool calls or resource reads. The pattern works by establishing a bidirectional processing chain where each middleware can inspect and modify requests before they reach handlers, then process responses on their return path. This creates clean separation between infrastructure concerns, logging, metrics, and business logic tools, resources, while maintaining a single execution flow. The asynchronous call next mechanism ensures non-blocking operation, and the hook hierarchy lets you target specific MCP operations with surgical precision. This approach solves the problem of scattering infrastructure code across your application by centralizing it in reusable components. You'd use this pattern when building production-grade MCP servers that need observability, security, or performance features without polluting your core logic. The trade-off is added complexity in debugging middleware interactions, but the modular design makes it easier to test and maintain individual concerns independently. Let's break it down. From FastMCP, import FastMCP. From FastMCP server middleware, import middleware. Middleware context. Imports the core FastMCP components. FastMCP is the main class for creating AI-callable tool servers, while middleware and middleware context provide the hook system for intercepting and processing messages before they reach your tools. This is the foundation for building extensible message processing pipelines. Class logging middleware. Middleware. The middleware that logs all MCP operations. This defines a middleware class that intercepts and logs MCP operations. Middleware pattern lets you wrap core functionality with reusable cross-cutting concerns like logging, auth, or metrics. Here it implements FastMCP's middleware base class to hook into the message pipeline. Async def on message, self context. Middleware context call next. Called for all MCP messages. Print F processing. Context method from context source. This is the middleware hook that intercepts every MCP message. The onMessage method logs the operation name and source before processing begins, creating an audit trail for debugging. This follows the standard middleware pattern where you inspect or modify context before calling the next handler. Result equals await call next. Context. This invokes the next middleware in the chain, passing control down the pipeline. The await ensures proper async execution order, while call next preserves the middleware pattern by delegating to subsequent handlers before post-processing.
Print F completed context method. Return result.
This logs completion of the MCP operation and returns the processed result. The pattern ensures middleware can inspect both the request and response, enabling full operation tracing, critical for debugging and monitoring in distributed systems.
Hash add middleware to your server. MCP equals FastMCP, my server. MCP, add middleware, logging middleware.
This instantiates the FastMCP server with identifier, my server, then registers the logging middleware. The middleware pattern intercepts all incoming messages, enabling cross-cutting concerns like logging without modifying core message handlers. Middleware interception pattern. The logging middleware demonstrates FastMCP's chain of responsibility design, where each middleware wraps the call next handler to pre-process and post-process messages without knowing the full execution chain. The await call next context line is mandatory. Omitting it breaks the middleware pipeline silently. This pattern enables cross-cutting concerns like logging, timing, and validation to be added declaratively without modifying core handlers.
The middleware that handles everything handles nothing.